under this paper that we've been looking at. Let's move on to another question. So the question reads, a 10 kg is placed on a rough horizontal surface and is acted upon by a force of 50 Newton at an angle of 30 degrees to the horizontal. Given that the coefficient of friction is 0.3, determine the acceleration of the box. All right, so this is the form of a diagram, but remember that they have given us the coefficient of friction, meaning there's also the issue of friction being talked about here, meaning we've got friction going in that particular direction like that. Okay, this is our friction. All right, so now the question is, how do we find the acceleration of the box? One thing that we need to understand is that we know Newton's second law of motion, which says summation of forces, and this time around it is the horizontal, so we can equate x. It should actually give us the mass multiplied by the acceleration in the x. So what we are looking for here, ladies and gentlemen, is very simple. We know the mass, or what you have to do is that find the forces in the x. So what we are going to do here, we are going to resolute this force. Remember, this is a 50 Newton force, right, acting at this particular angle to the horizontal. So we just have to go and resolute this. So we're going to, I'll do this. Okay, maybe let me not use blue. Let me use black. I'll resolute like this. So I'm going to find this is force y, and this is the force in the x. All together. So from there, you can clearly see that. Okay. So let's find the y component. The y component, it will be equal to f sine theta, which will be 50 sine 30 degrees, which I'm getting as 25 newtons. Okay. Then we also need to find the x. So let's find the fx. Fx, it will be f cos theta, which will be 50 cos 30 degrees. And I'm getting 43.3 newtons. This is very important because we need to know what we're dealing with. But remember that our acceleration is actually in the x. But there's the issue of friction here, right? And recall that friction force is given by mu multiplied by the normal force. Okay? Now, here's the thing. The mu is 0.3. Which one is our normal force? Come here. Remember that your normal force is perpendicular, is in the same direction as the mass or the weight, like that. Are we there, okay? Meaning, here in the y-axis, we don't just have one. Let me first do this. The sum of forces in the y, ladies and gentlemen, is not just one. No. So N is equal to mg. Okay? N is equal to mg, because remember that these guys are going in the opposite direction. But are these the only forces in the y? No. There's another one here. So this one is going down like this, then this one is going like this. So since this one is going down to be negative, Fy. Okay? Then our mass is 10, gravity will use 9.8 minus 25 in the y. So we can now find the normal force. So this is 9 and 8 minus 25. And our normal force is 73 newtons. Now that we know the normal force, we can now find the friction force, which is mu times the normal force. So the mu is 0.3. The normal force is 73. So what is friction? Friction is 21.9 newtons. This is very important. Keep it. Keep that. So now, let's go now to the sum of forces in the x. So sum of forces in the x, we only have fx and the fk. So sum of forces in the x is equal to max. Are we there? Now, in the x, we have this one, which is fx, which is 3.3. We say minus friction is always opposing motion. Okay? So it will be 21.9. All right? This is equal to m. M is what? Mass. What is the mass? 10. Then times the acceleration, ax. So subtract 43.3 minus 21.9. What are you getting? I'm getting 21.4. This is equal to 10 ax. over 10 over 10, and the acceleration is 2.14 meters per second squared.